Now the biomolecules. So after studying this unit, we will able to explain the characteristics of the biomolecules like the carbohydrates, proteins, and the nucleic acid and the hormones. Classify carbohydrates, proteins, nucleic acid, and the vitamins on the basis of their structure. Explain the difference between the DNA and the RNA. Describe the role of the biomolecules in the biosystem. Now, it is the harmonious. It is the harmonious and the synchronous process of the chemical reaction in the body which leads to the life. A living system grows, sustains, and reproduces itself. The most amazing thing about a living system is that it is composed of the non-living atoms and the molecules. The pursuit of the knowledge of what goes on chemically within the living system falls in the domain of the biochemistry. Living systems are made up of various complex biomolecules like carbohydrates, proteins, nucleic acid, lipids, etc. Proteins and carbohydrates are essential constituents of our food. These biomolecules interact with each other and constitute the molecular logic of the life processes. In addition, some simple molecules like the vitamins and the mineral salts also play an important role in the functions of the organisms. A structure and functions of some of these biomolecules are discussed in this unit. Now the carbohydrates. So carbohydrates are primarily produced by the plants and form a very large group of the naturally occurring organic compounds. Some common examples of the carbohydrates are the cane, sugar, glucose, starch, etc. Most of them have a general formula C6H2O by and they are considered as the hydrates of the carbon from where the name carbohydrate was derived. For example, the molecular formula of the glucose C6H12O6 fits into this general formula C6H2O6, but all the compounds which fit into this formula may not be classified as the carbohydrates. For example, acetic acid C3POH fits into this general formula C2H2O2 but is not a carbohydrate. Similarly, ramenose C6H12O5 is a carbohydrate but does not fit in this definition. A large number of their reactions have shown that they contain a specific functional group. Chemically, the carbohydrates may be defined as optically active polyhydroxyaldehydes for the ketones or the compounds which produce such units on the hydrolysis. Some of the carbohydrates which are fit in the taste are also called as the sugars. The most common sugar used in our homes is named as the sucrose, whereas the sugar present in the milk is known as the lactose. Carbohydrates are also called as the सैकराइड्स. ग्रीक में सैक्रम का मतलब होता है शुगर. इसके बाद फिर classification of the carbohydrates. The carbohydrates are classified on the basis of their behavior on the hydrolysis. They have been broadly divided into following three groups. पहला monosaccharides, a carbohydrate that cannot be hydrolyzed further to give the simpler unit of the polyhydroxyaldehyde or the ketone is called a monosaccharide. About 20 monosaccharides are known to occur in the nature. Some common examples are glucose, fructose, ribose, etc. फिर oligosaccharides, carbohydrates that yield 2 or to 10 monosaccharide units on hydrolysis are called the oligosaccharide. They are further classified as the disaccharides, trisaccharides, tetrasaccharides, etc. depending upon the number of the monosaccharides they provide on hydrolysis. Amongst these, the most common are the disaccharides. The two monosaccharide units obtained on the hydrolysis of a disaccharide may be same or different. For example, one molecule of the sucrose on the hydrolysis gives one molecule of the glucose and one molecule of the fructose, whereas the maltose gives two molecules of the only glucose. Now the polysaccharides, carbohydrates which yield a large number of monosaccharide units on the hydrolysis are called the polysaccharides. Some common examples are the starch, cellulose, glycogen, gums, etc. Polysaccharides do not fit in the taste, hence they are also called the non-sugars. The carbohydrates may also be classified either reducing or the non-reducing sugar. All those carbohydrates which reduce Fleming's solution and tolerance present are referred to as the reducing sugar. All the monosaccharides, their aldose or the ketose, are called the reducing sugars. Now the monosaccharides are further classified on the basis of the number of the carbon atoms and the functional group present in them. If a monosaccharide contains an aldehyde group, it is known as the aldose, and if it contains a keto group, it is known as the ketose. Number of the carbon atoms constituting the monosaccharide is also introduced in the name, as is evident from the examples given in the table 14.1. तो डिफरेंट टाइप्स ऑफ द मोनोसैकेराइड दिया हुआ है. पहला है ट्रायोज, फिर एल्डिहाइड एल्डोट्रायोज या कीटोज कीटोट्रायोज, फिर टेट्रोज एल्डोटेट्रोज और कीटोटेट्रोज, फिर पेंटोज एल्डोपेंटोज और कीटोपेंटोज, हेक्सोज एल्डोहेक्सोज और कीटोहेक्सोज, फिर हेप्टोज एल्डोहेक्सोज और कीटोहेप्टोज. उसके बाद आता है ग्लूकोज. तो glucose occurs freely in the nature as well as in the combined form. It is present in the sweet fruit and the honey. Ripe grapes also contain glucose in large amounts. It is prepared as the follow. तो पहला आता है from sucrose. From sucrose cane sugar. If sucrose is boiled with dilute HCl or the H2SO4 in the alcoholic solution, glucose and the fructose are obtained in the equal amounts. फिर इसका एग्जाम्पल है कि फिट 22H22O11 प्लस H2O सुक्रोज है, ये ग्लूकोज प्लस फ्रुक्टोज देगा C6H12O6 प्लस C6H12O6. Now from the starch, commercially glucose is obtained by the hydrolysis of the starch by boiling it with the dilute H2SO4 at a 393 Kelvin under the pressure. तो जैसे अब स्टार्च हो गया C6H10O5N प्लस H2O, H प्लस इसमें किए, H प्लस किए इसमें NH2O किए तो H प्लस 393 केल्विन पर 203 एटीएम तो NC6H12O6 और ग्लूकोज बन गया. इसके बाद फिर आता है स्ट्रक्चर ऑफ द ग्लूकोज. तो ये ग्लूकोज हो गया CHO, CHOH और C2OH. उसके बाद फिर आता है Glucose is aldohexose and is also known as the dextrose. It is the monomer of many of the large carbohydrates, namely starch, cellulose. It is probably the most abundant organic compound on the earth. It was assigned the structure given below on the basis of the following evidences. Its molecular formula was found to be C6H12O6. On prolonged heating with the HI, it forms N-hexane, suggesting that all the 6 carbon atoms are linked in the straight chain. जैसे HI और हीट किए तो यहाँ पर बन जाता है इसमें N-hexane बन जाता है. फिर आता है कि ग्लूकोज reacts with the hydroxylamine to form the oxime and adds a molecule of the hydrogen cyanide to give the cyanohydrine. These reactions confirm the presence of the carbonyl group phenol in the glucose. तो NH2OH हो गया तो ये बन जाएगा और फिर HCN है तो यहाँ पर CN और फिर इस तरह से बन जाता है. फिर चौथा इसमें आता है कि Glucose get oxidized to 6-carbon carboxylic acid, gluconic acid on reaction with a mild oxidizing agent like the bromine water. This indicates that the carbonyl group is present as an aldehydic group. जैसे Br2 वाटर है फिर ग्लूकोनिक एसिड इस ऐसे बन जाएगा. CHO है, CHOH4 है और C2OH है तो COOH, CHOH4 और C2OH बन जाएगा. फिर आता है इसमें fertilization of the glucose with the acetic anhydride gives the glucose pentaacetate which confirms the presence of the 5OH group. Since it is used as a stable compound, the 5OH group should be attached to the different atoms. जैसे acetic anhydride है और इसमें ऐसे किए तो ये बन जाता है. इसके बाद आता है कि on oxidation with the nitric acid, glucose as well as the gluconic acid both yield a dicarboxylic acid, saccharic acid. This indicates the presence of a primary alcoholic group in the glucose. जैसे ऑक्सीडेशन किए तो सैकरिक एसिड बन गया, फिर ग्लूकोनिक एसिड का ऑक्सीडेशन किए तो भी सैकरिक एसिड बन जाएगा. The exact spatial arrangement of the different OH group was given by the Fischer after studying many other properties. Its configuration is directly represented as the one. जो पहला वाला स्ट्रक्चर दिया हुआ है सो ग्लूकोनिक एसिड इज रिप्रेजेंटेड एज 2 एंड सैक्रिक एसिड इज 3. तो ये हो गया ये ग्लूकोनिक एसिड ये ग्लूकोनिक एसिड है. ग्लूकोनिक एसिड का स्ट्रक्चर ये दिया हुआ है और सैक्रिक एसिड का स्ट्रक्चर ये दिया हुआ है. फिर ग्लूकोज का जो स्ट्रक्चर है ये दिया हुआ है. उसके बाद फिर आता है कि ग्लूकोज is correctly named either D plus glucose. D before the name of the glucose represents the configuration, whereas the plus represents the dextrorotatory nature of the molecule. It should be remembered that D and L have no relation with the optical activity of the compounds. They are also not related to the letter D and the L. The meaning of the D and L notations is as follows. The letter D or the L before the name of any compound indicate the relative configuration of a particular stereoisomer of a compound with respect to the configuration of some other compound, configuration of which is known. In the case of the carbohydrate, this refers to their relation with a particular isomer of the glyceraldehyde. Glyceraldehyde contains one symmetric carbon atom and is used in isomeric form as shown below. तो पहला है ये है प्लस, ये हो गया प्लस ग्लिसरॉल्डिहाइड और ये हो गया माइनस ग्लिसरॉल्डिहाइड हो गया. फिर उसके बाद आता है कि प्लस आइसोमर ऑफ द ग्लिसरॉल्डिहाइड हैड a D configuration. It means that when its structure formula is written on the paper following a specific convention which you will study in the higher classes. The OH group lies on the right hand side in the structure. All these compounds which can be chemically correlated to the D plus isomer of the glyceraldehyde are said to have the D configuration, whereas those which can be correlated to the L isomer of the glyceraldehyde are said to have the L configuration. In the L isomer of the OH group is on the left hand side, as you can see in the following structure. For finding the configuration of the monosaccharide, it is the lowest asymmetric carbon atom as shown below, which is compared as in the plus glucose OH on the lowest asymmetric carbon is on the right side, which is comparable to the plus glyceraldehyde. For glucose is assigned D configuration. Other asymmetric carbon atoms of the glucose are not considered for this comparison. Also, the structure of the glucose and the glyceraldehyde is written in a way that most oxidized carbon, in this case CHO, is at the top. तो ये वाला है सी प्लस डी प्लस ग्लूकोसाइड का, और ये है डी प्लस ग्लूकोज का स्ट्रक्चर दिए हुए। इसके बाद फिर आता है कि द साइक्लिक स्ट्रक्चर ऑफ द ग्लूकोज। द स्ट्रक्चर वन ऑफ द ग्लूकोज एक्सप्लेन्ड मोस्ट ऑफ इट्स प्रॉपर्टी, बट द फॉलोइंग रिएक्शंस एंड द फैक्ट्स कुड नॉट बी एक्सप्लेन्ड बाय दिस स्ट्रक्चर। तो पहला, डिस्पाइट हैविंग द एल्डिहाइड ग्रुप, द ग्लूकोज डज नॉट गिव अ स्किफ टेस्ट एंड इट डज नॉट फॉर्म द hydrogen sulfide addition product with the NaHFO3. The pentacetate of the glucose does not react with the hydroxylamine, indicating the absence of the free CHO group. Glucose is found to exist in the two different crystalline forms, which are named as alpha and the beta. The alpha form of the glucose melting point 400 Kelvin is obtained by the crystallization from the concentrated solution of the glucose at 303 Kelvin, while the beta form's melting point 430 Kelvin is obtained by the crystallization from the hot and the saturated aqueous solution at 321 Kelvin. उसके बाद आता है दिस बिहेवियर कुड नॉट बी एक्सप्लेन्ड बाय द ओपन चेन स्ट्रक्चर वन ऑफ द ग्लूकोज. इट बाय प्रपोज दैट वन ऑफ द OH group may add to the CHO group and form a cyclic hemiacetal structure. It by found that glucose forms a six-membered ring in which the OH at the C5 is involved in the ring formation. This explains the absence of the CHO group and also existence of the glucose in the two forms as shown below. D2 cyclic forms exist in equilibrium with the open chain structure. यह है अल्फा डी ग्लूकोज और यह बीटा डी glucose. The two cyclic hemicrystal form of the glucose differ only in the configuration of the hydroxyl group at the C1 called the anomeric carbon. The aldehyde carbon before cyclization, such isomers, that means alpha form and the beta form, are called the anomers. The six-membered cyclic structure of the glucose is called the pyranose structure, alpha or the beta, in analogy with the pyran. Pyran is a cyclic organic compound with one oxygen atom and 5 carbon atom in the ring. The cyclic structure of the glucose is more correctly represented by the Haworth structure as given below. तो ये हो गया पायरन। इसके बाद फिर आता है अल्फा डी ग्लूकोपायरनोज और बीटा डी ग्लूकोपायरनोज, ये स्ट्रक्चर हो जाता है। फिर आता है फ्रुक्टोज। तो फ्रुक्टोज इज एन इम्पॉर्टेंट कीटोहेक्सोज. इट इज ऑब्टेन्ड अलॉन्ग विद द ग्लूकोज बाय द हाइड्रोलाइसिस ऑफ द डाइसैकेराइड सुक्रोज. इट इज द नेचुरल मोनोसैकेराइड फाउंड इन द फ्रूट, हनी एंड द वेजिटेबल. इन इट्स प्योर फॉर्म इट इज यूज्ड एज ए स्वीटनर. इट इज ऑल्सो इम्पॉर्टेंट कीटोहेक्सोज. इसके बाद आता है फिर स्ट्रक्चर ऑफ द फ्रुक्टोज. तो fructose also has the molecular formula C6H12O6, and on the basis of this reaction it was found to contain a ketonic functional group at the carbon number 2 and 6 carbon in the straight chain as in the case of the glucose. It belongs to a D-fridge and is a laboratory compound. It is appropriately written as a D minus fructose. Its open chain structure is as shown below. It also used in the two cyclic forms which are obtained by the addition of the OH at the C5 of the pseudolo group. The ring thus formed is a 5-membered ring and is named as the furanose with analogy to the compound furan. Furan is a 5-membered cyclic compound with 1 oxygen and the 4 carbon atom. तो ये हो गया डी फ्रुक्टोज का स्ट्रक्चर हो गया। उसके बाद फिर आता है फ्यूरन का स्ट्रक्चर ये हो जाता है। फिर आता है अल्फा डी फ्रुक्टोफ्रेनोज का स्ट्रक्चर ये आता है। फिर बीटा डी फ्रुक्टोफ्रेनोज का स्ट्रक्चर ये आता है। द साइक्लिक स्ट्रक्चर ऑफ द टू एनोमर्स ऑफ द फ्रुक्टोज आर रिप्रेजेंटेड बाय द हैवोथ स्ट्रक्चर एज द गिवन। तो अल्फा डी फ्रुक्टोफ्रेनोज ये हो गया और बीटा डी फ्रुक्टोफ्रेनोज ये हो गया। इसके बाद फिर आता है कि डाइसैकेराइड्स। तो यू हैव ऑलरेडी रीड दैट डाइसैकेराइड्स ऑन द हाइड्रोलाइसिस विद dilute acids for the enzymes yield two molecule of the either the same or the different monosaccharides. The two monosaccharides are joined together by an oxide linkage formed by the loss of the barter molecule. Such a linkage between the two monosaccharide unit through the oxygen atom is called the glycosidic linkage. In disaccharide, if the reducing group of the monosaccharide, that means the aldehydic or the ketonic groups are bonded, these are non-reducing sugars, that means example sucrose. On the other hand, sugar in which these functional group are free are called a reducing sugar, for example the maltose and the lactose. Sucrose, one of the common disaccharide is sucrose, which on hydrolysis gives equimolar mixture of the D plus glucose and the D minus फ्रुक्टोज। तो ये हो गया सुक्रोज। सुक्रोज में फिर डाला डी प्लस ग्लूकोज बन गया और डी माइनस फ्रुक्टोज बन गया। इसके बाद आता है these two monosaccharides are held together by a glycosidic linkage between the C1 of the alpha D glucose and the C2 of the beta D glucose. Since the reducing group of the glucose and the fructose are involved in the glycosidic bond formation, sucrose is a non-reducing sugar. तो ये अल्फा डी ग्लूकोज हो गया और ये बीटा डी ग्लूकोज हो गया और इसके बीच में एक ग्लाइकोसिडिक लिंकेज बना और इससे फिर सुक्रोज बन गया। फिर सुक्रोज इज ए डेक्सोरोटेटरी बट आफ्टर द हाइड्रोलाइसिस गिव्स डेक्सोरोटेटरी ग्लूकोज एंड लिवोरोटेटरी फ्रुक्टोज। सिंस द लेवोरोटेटरी ऑफ द फ्रुक्टोज minus 92.4 degree is more than the derotation of the glucose plus 52.5 degree, the mixture is levorotatory. Thus the hydrolysis of the sucrose brings about a change in the sign of the rotation from the dextro to levo and the product is named as the invert sugar. फिर उसके बाद आता है माल्टोज। अनदर डाइसैकेराइड माल्टोज इज कंपोज्ड ऑफ द टू अल्फा डी ग्लूकोज यूनिट्स इन विच द C1 of one glucose is linked to the C4 of the another glucose unit 2. The free aldehyde group can be produced at the C1 of the second glucose in solution and it for the reducing property for it is a reducing sugar. फिर यह है अल्फा डी ग्लूकोज, यह है अल्फा डी ग्लूकोज और यह है अल्फा डी ग्लूकोज और यह है माल्टोज। फिर इधर दिया हुआ है ये और फिर इसमें दिया हुआ है ये वाला दिया हुआ है। फिर आता है इसके बाद लैक्टोज। तो लैक्टोज इट इज मोर कॉमनली नोन एज द मिल्क शुगर सिंस दिस डाइसैकेराइड इज फाउंड इन द मिल्क इट इज कंपोज ऑफ द बीटा डी गैलेक्टोज एंड द बीटा डी ग्लूकोज। द लिंकेज इज बिटवीन द C1 of the galactose and the C4 of the glucose. The free aldehyde group may be produced at the C1 of the glucose unit, hence it is also called as the reducing sugar. तो ये हो गया बीटा डी गैलेक्टोज और ये हो गया बीटा डी ग्लूकोज और ये लैक्टोज का स्ट्रक्चर दिया हुआ है जिसमें ये एफा बॉन्ड होता है लैक्टोज में। फिर माल्टोज में अल्फा डी ग्लूकोज और अल्फा डी ग्लूकोज से बना हुआ है और माल्टोज में जो स्ट्रक्चर होता है कुछ ऐसा होता है। फिर उसके बाद सुक्रोज में देखें तो ग्लाइकोसिडिक लिंकेज है, तो सुक्रोज का जो स्ट्रक्चर है वो ग्लाइकोसिडिक लिंकेज का स्ट्रक्चर और ग्लाइकोसिडिक लिंकेज का जो स्ट्रक्चर है सुक्रोज का वो कुछ इस प्रकार से है जिसमें है अल्फा डी ग्लूकोज और बीटा डी फ्रुक्टोज। फिर माल्टोज में अल्फा डी ग्लूकोज और अल्फा डी ग्लूकोज। फिर उसके बाद फिर लैक्टोज में है बीटा बीटा, दोनों बीटे बीटे है लैक्टोज में। फिर आता है पॉलीसैकेराइड। तो polysaccharides contain a large number of the monosaccharide units joined together by the glycosidic linkage. These are the most commonly encountered carbohydrates in the nature. These mainly act as the food storage of the structural material. A starch is the main storage polysaccharide of the plant. It is the most important dietary source for the human being. High content of the starch is found in the cereal, root, tubers and some vegetable. It is a polymer of the alpha glucose and consists of the components amylose and the amylopectin. Amylose is water-soluble component which constitutes about 50 to 20% of the starch. Chemically, amylose is a long unbranched chain with 200 to 1000 alpha D glucose units held together by the C1 C4 glycosidic linkage. फिर आता है amylopectin is insoluble in the water and constitutes about 80 to 85% of the starch. It is a branched chain polymer of the alpha D glucose unit in which the chain is formed by the C1 to C4 glycosidic linkage, whereas branching occurs by the C1 C6 glycosidic linkage. तो ये हो गया अल्फ़ा लिंक और ये हो गया यहाँ पर भी अल्फ़ा लिंक है और ये एमाइलोज का स्ट्रक्चर दिए हुए हैं। इसके बाद फिर आता है सेलुलोज, ये अमाइलोपेक्टिन है और यहाँ पर है अल्फ़ा लिंक और ये ब्रांच एट C6 है, फिर अल्फ़ा लिंक है और फिर यहाँ पर भी अल्फ़ा लिंक दिए हुए हैं। फिर आता है सेलुलोज। तो सेलुलोज occurs exclusively in the plants and it is the most abundant organic substance in the plant kingdom. It is a predominant constituent of the cell wall of the plant cells. Cellulose is a straight chain polysaccharide composed of only beta D glucose units which are joined by the glycosidic linkage between the C1 of the one glucose unit and the C4 of the next glucose unit. तो ये सेलुलोज का दिया हुआ है, सेलुलोज है और सेलुलोज में ये बीटा लिंक्स यहाँ पर दिए हुए हैं। इसके बाद फिर आता है ग्लाइकोजन। तो glycogen, the carbohydrates are stored in the animal body as the glycogen. It is also known as the animal starch because its structure is similar to the amylopectin and is rather more highly branched. It is present in the liver, muscles, and the brain. When the body needs glucose, enzyme breaks the glycogen down to the glucose. Glycogen is also found in the yeast and the fungi. इसके बाद importance of the carbohydrates. So carbohydrates are essential for the life in both plants and animals. They form a major portion of our body. Honey has been used for a long time as an instant source of the energy by the Veds in the Ayurvedic system of the medicine. Carbohydrates are used as a storage molecule as a starch in the plants and the glycogen in the animals. Cell wall of the bacteria and the plants is made up of cellulose. We build furniture etc. from the cellulose in the form of wood and cloth ourselves with the cellulose in the form of the cotton fibers. They provide raw materials for many important industries like the textile, paper, lacquers, and the breweries. Two aldopentoses, namely the D-ribose and the 2-deoxy-D-ribose section, are present in the nucleic acid. Carbohydrates are found in the biosystem in combination with many proteins and the lipids. फिर उसके बाद क्वेश्चन आता है इन टेक्स्ट क्वेश्चन की ग्लूकोज और द सुक्रोज आर सोल्युबल इन द वाटर बट साइक्लोहेक्सेन और द बेंजीन सिंपल 6 membered रिंग कंपाउंड्स आर इनसॉल्युबल इन द वाटर एक्सप्लेन और व्हाट आर द एक्सपेक्टेड प्रोडक्ट्स ऑफ द हाइड्रोलिसिस ऑफ द लैक्टोज फिर हाउ डू एक्सप्लेन द एब्सेंस ऑफ द एल्डिहाइड ग्रुप इन द पेंटासिटेट ऑफ द डी ग्लूकोज ये हो गया इसके बाद फिर आता है प्रोटीन्स तो proteins are the most abundant molecules of the living system. Chief source of the protein are the milk, cheese, pulses, peanuts, fish, meat, etc. They occur in every part of the body and form the fundamental basis of the structure and function of the life. They are also required for the growth and the maintenance of the body. The word protein is derived from the Greek word proteos, which means primary or the prime importance. All proteins are polymer of the amino acids. फिर आता है amino acids. तो amino acids contains the amino group and the carboxyl group functional and the carboxyl functional groups depending upon the relative position of the amino group with respect to the carboxyl group. The amino group can be classified as the alpha, beta, gamma, delta, and so on. Only alpha amino acids are obtained on the hydrolysis of the protein. They may contain other functional group also. फिर आता है कि all alpha amino acids have trivial names which usually reflect the property of that compound or its source. Glycine is also named since it was sweet taste in the Greek. Glycose means sweet and the tyrosine by first obtained from the cheese in the Greek. Tyros means cheese. Amino acids are generally represented by a 3-letter symbol. Sometimes 1-letter symbol is also used. The structure of the sum commonly occurring amino acids along with their 3-letter and 1-letter are given in table 14.2. तो जैसे यहाँ पर जो दिया हुआ है ये है अल्फ़ा अमीनो एसिड जिसको आर साइड चेन कहते हैं। फिर यहाँ पर आता है कि ये जो दिया हुआ है ये है ग्लाइसिन एच तो ग्लाइसिन और जैसे ग्लाइसिन है तो एच सिंबल हो जाएगा कैरेक्टरिस्टिक फीचर ऑफ द साइड आर चेन और 3-लेटर सिंबल में उसका GL हो जाएगा और 1-लेटर कोड उसका G हो जाएगा। फिर आता है एलानिन तो एलानिन का CH3 हो गया और साइड चेन उसका है। फिर 3-लेटर सिंबल ALA है और 1-लेटर सिंबल में सिर्फ A है। फिर वैलिन आता है तो वैलिन में साइड चेन CH और CH3 के 2 है। फिर वैलिन और भी आता है। ल्यूसीन में साइड चेन एक और कार्बन बढ़ गया CH2 CH3 के 2 और ल्यूसीन और फिर इसमें L आ जाता है। फिर इसके बाद आता है आइसोल्यूसिन जिसमें साइड चेन ये होता है ILE और I आता है। फिर अर्जिनान जिसमें ये आता है आर्ज और R आता है। फिर लाइसिन जिसमें NH2 C2 के 4 लाइसिन और K आता है। फिर इसमें ग्लूटामिक एसिड जिसमें फिडोलोज C2 GLU और E आता है। फिर एस्पार्टिक एसिड जिसमें E आता है। इसके बाद फिर आता है ग्लूटामिन जिसमें फिर GLN फिर Q आता है। फिर अस्पार्जिनान जिसमें फिर ये आता है और फिर थ्रियोनिन जिसमें फिर ये आता है। इसके बाद सीरिन आता है। इसके बाद फिर आता है सीरिन में ये आ जाएगा जिसका सिंबल F हो जाएगा और 15 में फिर CH2SH CF और C आ जाएगा। मिथियोनिन में C3H CH2 मिथियोनिन मेट और M आ जाएगा। फिर फिनाइल एलेनिन में C6H5 CH2 PHE और F आ जाएगा और टायरोसिन में फिर ये आ जाएगा। फिर उसके बाद आता है ट्रिप्टोफान में TRPW आ जाएगा और हिस्टिडाइन में फिर HIF और H आ जाएगा। फिर आता है प्रोलीन में फिर प्रो और फिर P आ जाता है। इसके बाद फिर आता है कि इसेंशियल अमीनो एसिड्स जो दिए हुए हैं इसेंशियल अमीनो एसिड को स्टार से दिखाया गया है। तो इसमें से एंड ए वाला इंटायर स्ट्रक्चर है। तो इसेंशियल अमीनो एसिड्स को एक बार देख लेते हैं। जैसे इसेंशियल अमीनो एसिड में आता है इसेंशियल अमीनो एसिड्स में आता है, इसेंशियल अमीनो एसिड में आता है VIPMAL, वीआईपी मॉल। तो देखते हैं इसमें आता है कि नहीं आता है। तो सबसे पहले तो वैलिन आ गया, इसेंशियल अमीनो एसिड में वैलिन आ जाता है। फिर आता है लूसीन आता है, लूसीन आता है। फिर आता है आइसोल्यूसिन आता है। फिर आता है आर्जिनिन आता है। उसके बाद फिर लाइसिन आता है। फिर उसके बाद फिर थ्रियोनिन आता है, थ्रियोनिन आ जाता है। फिर मिथ्योनिन आ जाता है, मिथ्योनिन, एम से मिथ्योनिन। फिर फिनाइल एलिन आ जाता है, पी से फिनाइल एलिन आ जाएगा। और ट्रिप्टोफान आ जाएगा, तो इसका आ जाता है ट्राई वीआईपी मॉल। तो टी से फिर थ्रियोनिन आ जाता है, ट्राई वीआईपी मॉल। फिर हिस्टिडाइन आ जाता है, तो हिस्टिडाइन भी दिए हुए। और प्रोलिन, पी से फिनाइल एलिन, प्रोलिन नहीं है लेकिन हिस्टिडाइन है, तो ट्राई वीआईपी मॉल और हिस्टिडाइन भी आ जाता है जो कि इसेंशियल है। आइसोल्यूसिन, पी से प्रोलिन, पी से फिनाइल एलिन, एम से फिर आ जाएगा मिथ्योनिन, ए से आ जाएगा आर्जिनिन, एल से आ जाएगा हिस्टिडाइन, एल से लाइसिन और ल्यूसीन, और फिर एच से आ जाएगा हिस्टिडाइन, एक और आ जाता है। एच टी भी कर देते हैं, तो ये आता है टी एच भी हैप्पी मॉल, टी एच भी हैप्पी मॉल, ये आ जाता है। इसके बाद फिर क्लासिफिकेशन ऑफ द अमीनो एसिड्स देखते हैं। तो क्लासिफिकेशन ऑफ द अमीनो एसिड्स में amino acids are classified as acidic, basic or the neutral depending upon the relative number of the amino and the carboxyl group in their molecule. Equal number of the amino and the carboxyl group make it neutral, more number of the amino than the carboxyl group make it basic, and the more carboxyl group as compared to the amino group make it acidic. The amino acids which can be synthesized in the body are known as the non-essential amino acid. On the other hand, those which cannot be synthesized in the body and must be obtained through diet are known as the essential amino acids. उसके बाद फिर आता है ये जूटर आयन का दिया हुआ है, जूटर आयन का ऐसा दिया हुआ है। फिर उसके बाद आता है कि अमीनो एसिड आर यूजुअली colorless crystalline solids. These are water soluble high melting solids and behave like salts rather than the simple amines or the carboxylic acid. This behavior is due to the presence of the both acidic carboxyl and the basic amino groups in the same molecule. In the aqueous solution, the carboxyl group can lose a proton and the amino group can accept a proton, giving rise to a dipolar ion known as the Jutter ion. This is neutral but contains the positive and the negative charge दोनों. In the Jutter ion form the amino acids for amphoteric behavior as they react both with the acids and the bases. Except glycine, all other naturally occurring alpha amino acids are optically active. Since the alpha carbon atom is asymmetric, these exist in both D and the L form. Most naturally occurring amino acids have L configuration. L amino acids are represented by writing the NH2 group on the left hand side. फिर आता है स्ट्रक्चर ऑफ द प्रोटीन्स. तो यू हैव ऑलरेडी रीड द प्रोटीन्स. You have already read the protein as are the polymers of the alpha amino acids, and they are connected to each other by the peptide or the peptide bond or the peptide linkage. Chemically, peptide linkage is an amide formed between the pseudo OH group and the NH2 group. The reaction between the two molecules of the similar or the different amino acids proceeds through the combination of the amino group of one molecule with the carboxyl group of the other. This results in the elimination of the water molecule and the formation of the peptide bond CONH. The product of the reaction is called as a dipeptide because it is made up of the two amino acids. For example, when a carboxyl group of glycine combines with all the amino group of the alanine, we get a dipeptide जिसको glycyl alanine कहते हैं. If a third amino acid combines with dipeptide, the product is called a tripeptide. A tripeptide contains three amino acids linked by two peptide linkage. Similarly, when 4, 5 or the 6 amino acids are linked, the respective products are known as the tetrapeptide, pentapeptide or the hexapeptide respectively. When the number of the such amino acids is more than 10, then the products are called the polypeptides. A polypeptide with more than 100 amino acid residue having molecular mass higher than the 10,000 U is called the protein. However, the distinction between a polypeptide and a protein is not very sharp. Polypeptides with fewer amino acids are likely to be called proteins if they ordinarily have a well-defined conformation of a protein such as the insulin which contains the 51 amino acids. Now the proteins can be classified into two types on the basis of their molecular shape. पहला जो आता है वो आता है fibrous protein. When the polypeptide chains run parallel and are held together by the hydrogen and the disulfide bonds, then the fiber-like structure is formed. Such proteins are generally insoluble in the water. Some common examples are keratin present in the hair, wool, silk, and the myosin present in the muscles, etc. तो ये हो गया ग्लाइसिल एनालिन हो गया ग्लाई और एला, ये हो गया पेप्टाइड लिंकेज हो गया, फिर स्ट्रक्चर ऑफ दी प्रोटीन्स दिए हुए। इसके बाद फिर आता है ग्लोबुलर प्रोटीन, तो ये हो गया अल्फा हेलिक्स स्ट्रक्चर ऑफ द प्रोटीन हो गया और ये ग्लोबुलर प्रोटीन्स हो जाता है। और फिर हो जाएगा बीटा प्लेटेड शीट्स ऑफ द प्रोटीन्स हो जाता है ऐसा में। फिर आता है ग्लोबुलर प्रोटीन्स, तो दिस स्ट्रक्चर रियल्स व्हेन द चेन ऑफ द पॉलीपेप्टाइड्स coils around to give the spherical shape. These are usually soluble in the water. Insulin and the albumin are the common examples of the globular protein. A structure and the shape of the protein can be studied at 4 different levels, that means primary, secondary, tertiary, and the quaternary, each level being more complex than the previous one. The primary structure of the proteins may have one or more polypeptide chains. Each polypeptide in a protein has amino acids linked with each other in a specific sequence, and it is this sequence of the amino acids that is said to be primary structure of that protein. Any change in this primary structure, that means the sequence of the amino acid, creates a different protein. So the secondary structure of the proteins, the secondary structure of the protein refers to the shape in which a long polypeptide chain can exist. They are found to exist in two different types of the structure, namely the alpha helix and the beta pleated sheet structure. These structure arise due to the regular folding of the backbone of the polypeptide chain due to the hydrogen bonding and NH2 group of the peptide chain. फिर आता है उसके बाद अल्फा हेलिक्स। Alpha helix is one of the most common ways in which the alpha a polypeptide chain forms all possible hydrogen bonds by twisting into a right-handed screw helix with the NH group of the each amino acid residue to the hydrogen bonded to the pseudo of an adjacent turn of the helix as shown in the figure. In the beta pleated sheet structure, all the peptide chains are stretched out to nearly maximum extension and then laid side by side bare, which are held together by the intermolecular hydrogen bond. The structure resembles the beta-pleated fold of drapery and therefore is known as the beta-pleated sheet. फिर आता है tertiary structure of the protein. The tertiary structure of the proteins represents overall folding of the polypeptide chain. That means further folding of the secondary structure. It gives rise to two major molecular shapes, namely the fibrous and the globular. The main forces which stabilize the 2 degree and the 3 degree structure of the proteins are hydrogen bonds, disulfide linkage, van der Waals, and the electrostatic forces of the attraction. फिर आता है quaternary structure of the protein. Some of the proteins are composed of the two or more polypeptide chains referred to as the subunits. The special arrangement of these subunits with respect to each other is known as the quaternary structure. यहाँ पर दिया हुआ है diagrammatic representation of all these four structure is given in the figure 14.3 where each colored ball represents an amino acid. फिर उसके बाद ये दिया हुआ है प्राइमरी स्ट्रक्चर यहाँ पर दिया हुआ है, फिर सेकेंडरी स्ट्रक्चर यहाँ पर दिया हुआ है, फिर इधर दिया हुआ है टर्सरी स्ट्रक्चर, फिर इधर दिया हुआ है क्वाटरनरी स्ट्रक्चर दिया हुआ है। फिर उसके बाद डायग्रामेटिक रिप्रेजेंटेशन ऑफ द प्रोटीन स्ट्रक्चर, टू सब यूनिट्स ऑफ द टू टाइप्स इन द क्वाटरनरी स्ट्रक्चर का ये दिए हुए हैं। फिर उसके बाद फिर आता है प्राइमरी, सेकेंडरी, टर्सरी एंड द क्वाटरनरी स्ट्रक्चर ऑफ द हेमोग्लोबिन दिया हुआ है। तो प्राइमरी में इस तरह से दिया हुआ है, प्राइमरी में इस तरह से स्ट्रक्चर, फिर सेकेंडरी स्ट्रक्चर ऐसा, टर्सरी स्ट्रक्चर ऐसा और क्वाटरनरी स्ट्रक्चर फिर ऐसा दिया हुआ है। फिर आता है कि डीनेचुरेशन ऑफ द प्रोटीन। तो proteins found in the biological system with a unique three-dimensional structure and the biological activity is called a native protein. When a protein in its native form is subjected to a physical change like the change in the temperature or the chemical change like the change in the pH, the hydrogen bonds are disturbed. Due to this, globules unfold and helix get uncoiled and protein loses its biological activity. This is called a denaturation of the protein. During the denaturation, secondary and the tertiary structure are destroyed, but the primary structure remains intact. The coagulation of the egg white on boiling is a common example of a denaturation. Another example is a curdling of the milk, which is caused due to the formation of the lactic acid by the bacteria present in the milk. फिर आता है इन टेक्स्ट क्वेश्चन दिया हुआ है कि द मेल्टिंग पॉइंट एंड द सोलबिलिटी इन द वाटर ऑफ द अमीनो एसिड्स आर जनरली हायर दैन द corresponding halo acid. Explain. फिर वेयर डज द वाटर प्रेजेंट इन द एग गो आफ्टर बॉइलिंग द एग. Now the enzymes के बारे में कुछ लिखा हुआ है. तो enzymes तो life is possible Life is possible due to the coordination of the various chemical reaction in the living organism. An example is the digestion of the food, absorption of the appropriate molecule of diet, and ultimately production of the energy. This process involves a sequence of the reaction, and all these reactions occurs in the body under very mild condition. These occurs with the help of the certain biocatalyst called the enzyme. Almost all the enzymes are globular proteins. Enzymes are very specific for a particular reaction and for a particular substrate. They are generally named after the compound or the class of the compound upon which they work. For example, the enzyme that catalyzes the hydrolysis of the maltose into glucose is named as the maltase. तो जैसे ये C12H2011 माल्टेज है, इसको माल्टेज किया और C6H12O6 का दो मॉलिक्यूल बन गया ग्लूकोज में. इसके बाद आता है कि sometimes enzymes are also named after the reaction where they are used. For example, the enzymes which catalyze the oxidation of the one substrate with the simultaneous reaction of another substrate are named as the oxidoreductase enzyme. The ending of the name of an enzyme is the age. फिर इसके बाद आता है mechanism of the enzyme action. तो enzymes are needed by only in a small quantity for the progress of the reaction. Similar to the action of the chemical catalyst, enzymes are said to reduce the magnitude of the activation energy. For example, activation energy for the acid hydrolysis of the sucrose is 6.22 kJ per mole, while the activation energy is only 2.15 kJ per mole when hydrolyzed by the enzyme sucrase. Mechanism for the enzyme action has been discussed in the unit 5. इसके बाद फिर आता है vitamins. तो it has been observed that certain organic compounds are required in the small amounts in our diet, but their deficiency causes specific disease. These compounds are called the vitamins. Most of the vitamins cannot be synthesized in our body, but plants can synthesize almost all of them, so they are considered as the essential food factors. However, the bacteria of the gut can produce some of the vitamins required by us. All the vitamins are generally available in our diet. Different vitamins belong to various chemical classes, and it is difficult to define them on the basis of their structure. They are generally regarded as the organic compounds required in the diet in the small amount to perform the specific biological function for the normal maintenance of the optimum growth and the health of the organism. Vitamins are designated by the alphabets A, B, C, and D. Some of them are further named as the subgroups. For example, the B1, B2, B6, B12, etc. Excess of the vitamins is also harmful, and vitamin pills should not be taken without the advice of the doctors. Now, the term vitamin was coined from the word betel plus amine, since the earlier identified compound had amino group. Later word showed that most of them did not contain amino groups, so the letter E by dropped and the term vitamin is used these days. फिर आता है क्लासिफिकेशन ऑफ द विटामिन्स में. तो vitamins are classified into two groups depending upon their solubility in the butter or the fat. There's a fat soluble vitamins. Vitamins which are soluble in the fat and the oils but insoluble in the butter are kept in this group. Are these are vitamin A, D, E, and K. They are stored in the liver and oppose fat storing tissues. फिर butter soluble vitamins B group vitamins and the vitamin C are the soluble in the butter, so they are grouped together. Butter soluble vitamins must be supplied regularly in the diet because they are readily excreted in the urine and cannot be stored except vitamin B12 in our body. Some important vitamins and their sources and DH called by their deficiency are listed in table 14.3 में दिया हुआ है. जैसे some important vitamins, their sources and their deficiency disease. जैसे विटामिन ए का दिया हुआ है तो फिश लिवर ऑयल कैरोट्स बटर एंड द मिल्क हो गया. फिर जीरोप्थोल्मिया हो गया, हार्डनिंग ऑफ द कॉर्निया ऑफ द आई, और नाइट ब्लाइंडनेस इसका हो जाता है डिफिशियंसी डिजीज में. फिर विटामिन B1 आता है जिसको थायमिन भी कहते हैं. यूज्ड टू मिल्क ग्रीन वेजिटेबल्स एंड द सीरियल्स में मिलता है. उसके बाद फिर बेरी लॉस ऑफ द एपेटाइट रिटार्डेड ग्रोथ होता है. फिर विटामिन B12 जिसको रिबोफ्लेविन कहते हैं मिल्क एग वाइट और द लिवर किडनी में मिलता है. चिलियोसिस फिशरिंग एट द कॉर्नर्स ऑफ द माउथ एंड द लिप्स, डाइजेस्टिव डिसऑर्डर एंड बर्निंग सेंसेशन ऑफ द स्किन होता है. फिर विटामिन B6 जिसको पायरोडॉक्सिन कहते हैं यूज्ड मिल्क एग योल्क और सीरियल्स एंड द ग्रेन्स में होता है जिसको कन्वर्जेंस जिससे हो जाता है. फिर विटामिन B12 मीट फिश एग एंड द कर्ड में होता है. पेनिसिस अनेमिया एंड आरबीसी डिफिशिएंट इन दी हेमोग्लोबिन हो जाता है जिससे. फिर विटामिन सी जिसको एस्कॉर्बिक एसिड कहते हैं तो सिट्रस फ्रूट आंवला और दी ग्रीन लीफी वेजिटेबल्स में मिलेगा और जिसकी डिफिशियंसी से स्कर्वी हो जाता है जिससे ब्लीडिंग कम करते हैं. फिर विटामिन डी एक्सपोजर टू द सनलाइट में मिलेगा. फिश एंड एग वाटर में मिलेगा. रिकेट्स बोन डिफॉर्मिटी इन चिल्ड्रन एंड ऑस्टियोपोरोसिस ऑस्टियोलोमेशिया सॉफ्ट बोन्स एंड द जॉइंट पेन इन द एडल्ट हो जाएगा. इसके बाद फिर आता है विटामिन ई आता है. तो विटामिन ई वेजिटेबल ऑयल्स लाइक द व्हीट जर्म ऑयल सनफ्लावर ऑयल एक्सेट्रा मिलता है और इसके डिफिशियंसी से इंक्रीड फ्रैगिलिटी ऑफ द आरबीसी एंड द मस्कुलर वीकनेस हो जाता है. फिर आता है विटामिन के जो कि ग्रीन लीफी वेजिटेबल्स इंक्रीड ब्लड क्लॉटिंग ऑन द टाइम में मिलता है. इनके ब्लड कोटिंग टाइम जिससे बढ़ जाता है, ब्लड का क्लॉथिंग होने का टाइम जिससे क्या हो जाएगा तो बढ़ जाएगा। फिर आता है न्यूक्लिक एसिड। तो न्यूक्लिक एसिड क्या दिया हुआ है कि एवरी जनरेशन ऑफ ईच एंड एवरी स्पीसीज ऑफ द रिएम्बल फीड एंसेस्टर इन मैनी बेज, हाउ आर द कैरेक्टरिस्टिक ट्रांसमिटेड from the one generation to the next mate. It has been observed that nucleus of a living cell is responsible for this transmission of the inherent character, also called the heredity. The particles in the nucleus of the cell responsible for the heredity are called the chromosome, which are made up of the proteins, and another type of biomolecules called the nucleic acid. These are mainly of two types: deoxyribonucleic acid and the ribonucleic acid (RNA). Since nucleic acid are held a long chain polymer of the nucleotides, so they are also called the polynucleotides. ये दिया हुआ है जेम्स डेवी वाटसन का। तो बॉर्न इन द शिकागो इलिनॉइस इन द 1928, डॉक्टर वाटसन received his PhD from the Indiana University in the zoology. He is best known for his discovery at the structure of the DNA, for which he shared with the Francis Crick and the Maurice Wilkins in the 1952 Nobel Prize in the Physiology and the Medicine. They proposed that DNA molecule takes the shape of a double helix in the elegantly simple structure that resembles a gently twisted ladder. The rails of the ladder are made of the alternating units of the phosphate and the sugar deoxyribose. The rungs are each composed of a pair of the pyrimidine base, etc. This research laid the foundation for the emerging field of the molecular biology. The complementary pairing of the nucleotide base explains how identical copies of the parental DNA pass on to the two daughter cells. That is research launched a revolution in the biology that led to the modern recombinant DNA technique. फिर आता है इसके बाद कि द केमिकल कंपोजिशन ऑफ द न्यूक्लिक एसिड। तो complete hydrolysis of the DNA or the RNA yield a pentose sugar, phosphoric acid, and a nitrogen containing heterocyclic compound called the basage. In DNA molecule, the sugar moiety is the beta D2 deoxyribose, whereas in the RNA molecule it is the beta D ribose. तो ये बीटा डी राइबोज का स्ट्रक्चर हो गया, आई बीटा D2 डीऑक्सी राइबोज का स्ट्रक्चर हो गया। इसके बाद फिर आता है कि DNA contains four bases, namely the adenine, guanine, cytosine, and the thymine. That RNA also contains four bases. The first three bases are same as in DNA, but the fourth one is the uracil U. तो ये एडेनिन का स्ट्रक्चर है, ये ग्वानिन का स्ट्रक्चर है, ये साइटोसिन का स्ट्रक्चर है, थायमिन का स्ट्रक्चर है और ये यूरासिल का स्ट्रक्चर दिए हुए हैं। फिर जैसे कि इसमें देख सकते हैं कि एडेनिन और द एजी में दो गो रिंग है, लेकिन कट में जो है एक गो रिंग है, और इसका जो ई वाला रिंग और ई वाला रिंग सेम है, मतलब ये वाला रिंग NC NH फिर NCC और फिर NH इसमें भी है, और फिर CN फिर NH2 इसमें भी आता है, फिर ये रिंग और ये रिंग सेम है। फिर इसके बाद स्ट्रक्चर ऑफ द न्यूक्लिक एसिड। तो a unit formed by the attachment of a base to the one dash position of the sugar is known as the nucleoside. In the nucleoside, the sugar carbons are numbered at the 1 dash 2 dash 3 dash etc. In order to distinguish this from the basage, the nucleoside is linked to the phosphoric acid at the 5 dash position of the sugar moiety, we get a nucleotide. तो स्ट्रक्चर ऑफ द न्यूक्लियोसाइड एंड द न्यूक्लियोटाइड दिया हुआ है। तो ये है न्यूक्लियोसाइड और ये है न्यूक्लियोटाइड। इसके बाद फिर आता है न्यूक्लियोटाइड आर ज्वाइंड टुगेदर। Nucleotides are joined together. Nucleotides are joined together by the phosphodiester linkage between the 5' and 3' carbon of the pentose sugar. The formation of the typical dinucleotide is shown in the figure 14.6 में दिए हुए हैं। तो यहाँ पर दिए हुए ये फॉर्मेशन ऑफ द डाइन्यूक्लियोटाइड दिया हुआ है। तो यहाँ पर है शुगर बेस और शुगर बेस फिर फॉस्फोडाइस्टर लिंकेज यहाँ पर बन गया, फिर ये एंड ऑफ द चेन यहाँ पर हो गया। फिर उसके बाद आता है सिंपल वर्जन, ये यहाँ पर डबल स्ट्रैंड ऑफ द हेलिक्स स्ट्रक्चर ऑफ द DNA दिया हुआ है। फिर यहाँ पर दिया हुआ है ए सिंप्लीफाइड वर्जन ऑफ द न्यूक्लिक एसिड चेन इज शोन बिलो। तो यहाँ पर शुगर बेस फॉस्फेट फिर शुगर बेस फॉस्फेट N और शुगर बेस इस तरह से दिया हुआ है। फिर information regarding the sequence of the nucleotides in the chain of a nucleic acid is called its primary structure. Nucleic acid have a secondary structure also. James Watson and the Francis Crick gave a double-stranded helix structure of the DNA. Two nucleic acid and the chains are wound about each other and held together by the hydrogen bonds between the pairs of the bases. The two strands are complementary to each other because the hydrogen bonds are formed between the specific pairs of the bases. Adenine forms the hydrogen bond with the thymine, whereas the cytosine forms the hydrogen bond with the guanine. In the secondary structure of the RNA, single-stranded helix is present, which sometimes fold back on itself. RNA molecules are of the three types, and they perform different functions. They are named as the messenger RNA, mRNA, and ribosomal RNA, rRNA, and transfer RNA, tRNA. इसके बाद फिर आता है कि हरगोविंद खुराना के बारे में दिया हुआ है। तो हरगोविंद खुराना was born in 1922 में। He obtained his MSc degree from the Punjab University in the Lahore. He worked with the Professor Vladimir Pilog, who molded Khurana thoughts and philosophy towards the science, work and the effort. After a brief stay in the India in the 1949, Khurana went back to the England and worked with the Professor G.W. Kinner and the Professor A.R. Todd. It was at the Cambridge, UK that he got interested in both proteins and the nucleic acid. Dr. Khurana shared the Nobel Prize of the Medicine and Physiology in the 1968 में with the Marshall Nierenberg and the Robert Hawley for cracking the genetic code. फिर उसके बाद फिर आता है DNA fingerprinting. So it is known that every individual has unique fingerprints. These occur at the tips of the fingers and have been used for the identification for a long time, but these can be altered by the surgery. A sequence of the base of the DNA is also unique for a person, and information regarding this is called DNA fingerprinting. It is same for the every cell and cannot be altered by any non-chemical treatment. DNA fingerprinting is now used in the forensic laboratory for identification of the criminals, to determine the paternity of an individual, to identify the dead body in any accident by comparing the DNA of the parents or the children, to identify a racial group, to rewrite the biological evolution. फिर उसके बाद आता है बायोलॉजिकल फंक्शन ऑफ द न्यूक्लिक एसिड. तो डीएनए द केमिकल बेसिस ऑफ द हेरिडिटी एंड मे बी रिगार्डेड एज द रिजर्व ऑफ द जेनेटिक information. DNA is exclusively responsible for the maintaining the identity of the different species of the organism over millions of the years. A DNA molecule is capable of self-duplication during the cell division, and identical DNA strands are transferred to the daughter cells. Another important function of the nucleic acid is protein synthesis in the cell. Actually, the proteins are synthesized by the various RNA molecule in the cell, but the message for the synthesis of a particular protein is present in the DNA. फिर उसके बाद आते हैं हार्मोन्स. तो हार्मोन्स आर द मॉलिक्यूल दैट एक्ट एज द इंटरसेलुलर मैसेंजर्स. These are produced by the endocrine glands in the body and are poured directly into the blood stream, which transport them to the site of the action. In terms of the chemical nature, some of these are steroids, for example estrogen and the androgen. Some are polypeptides, for example insulin and the endorphins, and some other are amino acids derivatives such as the epinephrine and the norepinephrine. Hormones have several functions in the life in the body. They help to maintain the balance of the biological activities in the body. The role of the insulin in keeping the blood glucose level within the narrow limit is an example of this function. Insulin is released in the response to the rapid rise in the blood glucose level. On the other hand, hormone glucagon tends to increase the blood glucose level in the blood. The two hormones together regulate the glucose level in the blood. Epinephrine and the norepinephrine mediate the response to the external stimuli. Growth hormones and the sex hormone play a role in the growth and the development. Thyroxine produced in the thyroid gland is an iodinated derivative of the amino acid tyrosine. Abnormally low level of the thyroxine leads to the hypothyroidism, which is characterized by the uh, lethargenesis and the obesity. Increased level of the thyroxine cause the hyperthyroidism. Low level of the iodine in the diet may be lead to the hyperthyroidism and the enlargement of the thyroid gland. This condition is largely being controlled by the adding sodium iodide to the commercial table salt, जिसको iodide salt कहते हैं. Steroid hormones are produced by the adrenal cortex and the gonads, testes in the males and the ovaries in the females. Hormones released by the adrenal cortex play a very important role in the functions of the body. For example, glucocorticoids controls the carbohydrate metabolism, modulate inflammatory reaction, and are involved in the reaction to the stress. The mineralocorticoids control the level of the excretion of the water and salt by the kidney. If the adrenal cortex does not function properly, then one of the results may be Addison's disease characterized by the hyperglycemia, weakness, and increased susceptibility to the stress. The disease is fatal unless it is treated by the glucocorticoids and the mineralocorticoids. Hormones released by the gonads are responsible for the development of the secondary sex character. Testosterone is the major sex hormone produced in the males. It is responsible for the development of the secondary male character, tip, voice, facial hair, general physical constitution, and the estradiol is the main female sex hormone. It is responsible for the development of the secondary female characteristic and participates in the control of the menstrual cycle. Progesterone is responsible for the preparing the uterus for the implementation for the fertilized eggs. उसके बाद इन टेक्स्ट क्वेश्चन दिया हुआ है कि भाई कैन नॉट विटामिन सी बी स्टोर्ड इन आवर बॉडी. दूसरा क्वेश्चन कि भाट प्रोडक्ट्स वुड बी फॉर्मेड व्हेन ए न्यूक्लियोटाइड फ्रॉम द डीएनए कंटेनिंग थायमिन इज हाइड्रोलाइड. तीसरा है कि व्हेन आरएनए इज हाइड्रोलाइड देयर इज नो रिलेशनशिप among the quantity of the different bases obtained. Bhat does this fact suggest about the structure of the RNA. फिर इसका समरी है कि carbohydrates are the optically active polyhydroxyaldehydes for the ketones for the molecules which provide such units on the hydrolysis. They are broadly classified into three groups: monosaccharides, disaccharides, and the polysaccharides. Glucose, the most important source of the energy for the mammals. It is obtained by the digestion of the starch. Monosaccharides are held together by the glycosidic linkage to form the disaccharide or the polysaccharides. Proteins are the polymers of the about 20 different alpha amino acids which are linked by the peptide bonds. 10 amino acids are called the essential amino acids because they cannot be synthesized by our body, hence must be provided through the diet. Proteins perform various structural and dynamic functions in the organism. Proteins which contain only alpha amino acids are called the simple proteins. The secondary or the tertiary structure of the proteins get disturbed on changing the pH of the structure, on the changing the pH of the temperature, and they are not able to perform their function. This is called the denaturation of the protein. Enzymes are biocatalysts which speeds up the reaction in the biosystem. They are very specific and selective in their action, and chemically majority of the enzymes are proteins. Vitamins are the necessary food factors required in the diet. They are classified as the fat soluble A, D, E, and K, water soluble B and C, and deficiency of the vitamins lead to the many disease. इसके बाद फिर आता है कि न्यूक्लिक एसिड आर द पॉलीमर ऑफ द न्यूक्लियोटाइड्स which in turn consist of the bases, a pentose sugar, and the phosphate moiety. Nucleic acid are responsible for the transfer of the character from the parents to the offspring. There are two types of nucleic acid, DNA and the RNA. DNA contains the 5 carbon sugar molecule called a 2-deoxyribose, whereas the RNA contains the ribose. Both DNA and RNA contains the adenine, guanine, and the cytosine. The fourth base is thymine in the DNA and uracil in the RNA. The structure of the DNA is a double bond strand, whereas the RNA is a single strand molecule. DNA is the chemical basis of the heredity and have the coded message for the protein to be synthesized in the cell. There are three types of the RNA: mRNA, RNA, and the tRNA, which actually carry out the protein synthesis in the cell.